Today is August 14th, 2025. You have found the Community Code Review, the Datum Dons. We call ourselves the Datum Dons, and we're presented by the good people at Gimbalabs. So what we do here is we explore Aiken Validator code, coders hanging out, working and exploring code, line by line, question by question, person by person. We have Dons and we have capos. Let's get into it. Who is the Don? And who?
I'm the
There he is. Jason's the Don. And who are the capos? I'll be a capo today.
Likewise, Lewis here.
Lewis is a capo.
Yeah, I'm Harsha and I'm also a capo.
Right. And do we have any others?
Unspent here.
Yes, Unspent is a capo. And I think we have a guest today.
We have two guests. We have Ahmed as usual, and we have Ken.
All right. Welcome, Ahmed and Ken. Hey, Don, are we ready? Are you ready to take it?
Yes. So we're looking at a crowdfunding validator here, whereby people are able to crowdfund to a particular campaign, whereby a creator can create a campaign and then people can back that campaign. So in particular, what we're doing today is we're doing the claim funds part of the validator. So this is whereby in case a campaign ends and then the funds have not reached the target, we want to be able to, for the campaign creator to return the funds that are in the campaign to the people who supported. So that is what we're going to do today.
So we are going to do refund if the goal is not reached.
Yes.
Okay. So do you want to give like a quick rundown of like the basic logic so that everyone's on the same page?
Okay. So for this validator, it's a spend validator, and with that we also have Datum that kind of holds the data for the campaign. And this Datum has a lot of fields, but the main ones are the goal. So this represents the amount of funds that are supposed to be reached. And then we have the current amount. So these are the amount of funds that have been donated or funded or sent to the campaign by backers. And then we have the backer, who's basically it's identified for anyone who backs the campaign. And then we have the key hash for the creator. This is the person who created the campaign. So the reason we have this, so the important ones are the creator one. So this is used to kind of verify that you can do certain actions. It's because certain actions can only be run by the creator. So this includes canceling the campaign, refunding, and also claiming the funds when the goal has been reached. So the part that any random person with a public key hash can do is the support campaign. So this is the action that anyone can do. So this is this action also changes the data by changing the current funds. Yeah. So another important field is the deadline. So this is one of the fields you're going to be checking to see whether the deadline has been reached and also whether the current funds have either exceeded or not exceeded the goal. So those are the main fields of the data. We also have the actions. You can call this it's part of the redeemer, but also it's what kind of things you can do to this script validator. So
yeah.
So I think I walked through them a bit. I don't know if I can go through them again.
Yes, I think you walked through it pretty well. So the action is an
Yeah.
integer that can be these four numbers, 0, 1, 2, or 3. So for each number, it's a different action. For example, if the action is 0, it's a cancel campaign. If it is 3, if it is a refund. 2, it is a claim, and 1, it is a support campaign. Does anyone have any questions at this moment before we start writing some code?
Also, it's important that we have the campaign ID when we're doing
the campaign
funding.
ID. Yes,
Yeah,
right
so that
here.
you fund the right.
Yeah.
Also, we have it in the datum, and also we have it in the redeemer action.
Yes.
So
Yes.
it's part of the action, so that we know exactly which campaign we are funding, because there could be many campaigns with different IDs using the same kind of validator.
Yeah, makes sense.
Okay.
All right.
So another datum that we added last time is the Barker datum. And this one is for identifying the people who fund the campaign, so that in case we want to refund them, we know which address to send the funds to.
Yes.
And so that's
Yeah, okay.
So I
So
have like a small input on the backer datum. So I was looking into other validators, and the backer address shouldn't directly be a backer address. It should just be the backer verification key hash, because the address can be derived from the verification key hash. So the verification key hash seems to be a standard and not the address, because I'm not sure if there is like a address type that the validator directly accepts.
all right, I think that's a good addition, because I think we
Yeah,
can
so
add
I'm
that.
going to
Using address and datum always is annoying to look at as well, because it's like super nested in a bunch of different constructors, right?
yes.
Yeah, let's look at the
Yes, and
let's
that's
go to
why verification key
you can
hash
stop
is the most basic.
Yeah, I'm glad you said that out loud, because I hate using addresses and have rarely seen other people use it, but I keep seeming to do it.
Yeah.
is the verification key hash is just less nested because the address is it's an object of a bunch of other stuff. That's the deal.
Yeah, and address is also not straightforward. For example, let's quickly go to our favorite thing, docs.
Yes, I knew it.
If you
Yeah,
look at the type address, you'll see that it's not just a string. It is this. This is the type.
right.
So we
So
can't
can we
directly
get
put it in.
can we get the both of those? Can we get the payment credentials and the stake credentials from the verification key hash?
So we won't be needing the stake credential.
But just like, because now I'm thinking about not using addresses. And okay, but what if I was using an address and I was using it because I needed the stake address? If I went to the verification key hash method, can I still derive all of that information?
So
Or do you just get the address?
you can get the address from the verification key hash.
Yeah.
Yeah, let's try to track that down. Payment credential.
So I do
Like,
remember seeing this, but I can't remember where I saw it. I think maybe it's an Aiken, and maybe it's an Asteria code that I saw them use this.
Yeah.
Jason, do you have any ideas? Have you seen this pattern before?
So I think okay, I think the verification key is used to create the credential. So it's we can use the verification key thing as a data constructor for the credential.
Correct.
So if you have the verification key hash, so we can use that as the input, quote unquote input, to the data constructor verification key, which is a credential, and then we can use that credential
to derive the address.
But I'm not sure about that. I'm not sure about if you can use it as a payment credential, but I think that's a pattern you can use.
So the payment credential is just a credential.
Okay, so then you can use it.
Yeah. So this is just like you build this and it goes directly here. And I don't know how we exactly do it, but like, yeah, let's start exploring.
Yeah. Well, I was just
saying,
if you'd scroll down and check out what payment credential is.
It's just credential.
Oh, it's credential. Okay.
It's just credential. Oh, okay.
Yeah.
What about script credential?
What is it?
Or the stake credential?
Yeah, that is what I'm confused about. So what happens if an address has the stake credential? So what do we even need this? Is what I'm
It would
thinking.
change the result of the address, like the ADD1, right? That byte string that we think of, that would change if the stake credential was different. So you had the same payment credential, but then you pass to 2 different stake credentials, the end result address would be different for those.
Correct. So the way they did it is they didn't actually derive the address. They just like derived they just checked if the payment, so the verification key hash is a part of this address, is used to build this address, and they just checked if that verification key hash is the same as the other verification key hash on the datum.
Cool. Yeah, that makes sense. And what are we even doing with this in particular? Are we
So
tagging
this
the
is
outputs, making sure the value is going to the specific address we want?
yes.
Yeah.
That's what I think. Jason, is that what you have in mind?
Yeah, that's what I have in mind. So we want the address so that you can send the refund back to the right person.
Okay.
Cool.
All right.
So now, so we have a minimal spend validator here, and so the important thing to note here is that we are extracting the data from the parameters so that we can, since we have 2 types of data, so that we can match the right one, and then after matching with the right one, we can now do the refund.
Yeah.
So
we are, for the first 2 lines, we're just unwrapping the datum from the option, and then this datum is being used in the actions, right?
yes, it's been used in the, okay, so one of the datums, the CF datum, is used in the console campaign action, in the support campaign action, and also in the claim funds action. But then the Barker datum is used in the refund action. So that's why we need to match the different ones.
Yes. So I have one more question here. So this specific spend validator goes through each of the UTXOs, right? And this specific validator makes sense if the spending UTXO is the UTXO that has the that is the campaign UTXO, which has this datum, correct? But shouldn't we write like a slightly different part when this UTXO is one of the backer UTXOs?
Okay, so how do you differentiate between the Barker UTXO and the
campaign UTXO?
Yeah, because the campaign UTXO is a thread token, right? So it's a token we use to maintain state, right?
Yes.
And then the Barker UTXO is the many Barker UTXOs, right? Because every Barker creates one in there.
Exactly. So I think it has to do with the type of datum that's in the UTXO. If it is this datum, then we know it is the campaign UTXO, which is used to maintain state. But if it is this datum, we know it is the backer datum. And if it is some other datum, then we don't even consider it.
Yeah, I think that's so. So we can get the UTXO will have its datum, right?
Correct. Or at least we'll have to check for it. Okay, because right now we only said it is of the type data, so it can be any subtype of datum.
Yeah. So I think in the branch 3, the refund branch, I think we can we can have a when, like a pattern matching clause, which checks for the unwrapped datum.
When so actually you can write it, Jason, instead of me writing it.
Right.
And then follow him so we can watch his train of thought.
Oh yeah.
What was that?
Follow Jason.
Oh, follow Jason. Yes.
Okay. Yeah, normal shortcuts. Okay, so we go to the refund campaign here, and then so here's where we do the command statement. So we have the CF datum. So in this case, unwrapped. So we pass in that, and I'm not sure this is the right way to.
So
we'll clean it up. Yeah, it's hard to write on the hot seat for sure.
So yeah, so here I think we can just false because we don't want this. And then
Okay.
and then here is when we do this stuff. I don't know why this is here.
No, we can do all that.
What we had last time. So we had an expect, but now, so I don't know if these two are similar in that the
So
expect will
is this like a different type of way of writing it? Because we usually use when is when, is this a different type?
okay, no. I think it's the same. I just messed with it. I'm thinking of a different language.
Okay, you're just thinking. Yeah,
It's the
go
same.
for it.
Yeah, it's the
Go
same
for
thing.
it. Go
Yeah.
for it.
Sorry about that. So it's just when datum. I'll just and then is
Yeah.
so I think it should be like that.
Yeah.
I think I'm missing a few things, but yeah. There you go.
Hmm.
Yeah, and let me quickly change this up. So it's that arrow thing that you need to put. Okay.
And then here, I think is where we do the logic now of the refund.
Mm-hmm.
So now here is where we sign, where we check if the backer signed it, and the other stuff, like if the output is going to the right address, and if, all these checks.
Yeah.
So Jason, I have a small question. Can this not also be in the high level? Like even before 0, 1, 2, where is that? Even before like we do the 0, 1, 2 here, can we not do that in the high level and then check the 0, 1, 2?
I think we can do that. So we do it here and then we check the redeemer action, but will that repeat code or something?
No, I'm just thinking about which one would be like would we be repeating it either way? Yeah, I guess like let's go for it and then we can figure out the most optimal way of doing it.
All right.
Yeah.
So we do it after the expect, right?
Yes. Yeah.
Okay.
No, but this is good. This is good. Keep going. Keep going.
So do we change it now or?
No, you can keep going as is, and then we'll change it later.
Okay.
Because now we're getting down into the meat. This is the real, like this, that string together of those logical and statements are really what is going on here. Understanding that and tracking that back up would be great.
Okay. So now here in this, Okay. So now I think we can go over the checks when we want to check, right? So the important one is we want to check if the output of this transaction is going to the right address. So I think the first thing we need to do is we need to construct the address, right?
Correct.
And so
we need to deconstruct the address, I think, instead of construct the address, So we need to get the verification key hash from the address we get from the outputs, where we get the address from the output, and we check if it is built with the same verification key hash.
Yeah, definitely. So that is better than constructing it from the Baka Datum verification key hash and then comparing it to the
correct
address in the output. Okay.
Correct.
Right. So we can get that from the UTXO, the output reference. So
yes.
The particular output reference, like if you go to the documentation, it has a particular field.
Yes, I can go to that. You just output reference.
Yeah,
or in this case, we are just checking outputs. Are you planning to check outputs or the UTXO we are spending?
we need to check the UTXO we're spending, but also I
Yes.
think
So we have these two for the output reference, if it's just the output reference. So what we can do, at least in my opinion, I've seen this pattern before. We take this output reference and we find the input that has this output reference, and then we access the output section of that input. For example, if we find the input that has this output reference,
I think find input is
yeah. So input is made of the output reference and the output, right?
Yeah.
So we have this. So if we can get this input, then we can access this output section. And in the output section, we have the address. And we can
Yes.
destructure this address to get the verification key hash.
Oh my God.
Yes. Okay, that is all correct. So we need find input function.
Yes.
So that should be in the library, in the transactions.
Yes, it'll be in the transaction. It is one of the fields in the transaction. So we'll have to destructure the or directly say transaction.inputs. Let me actually show you. I'll open up the transactions object.
No, I was referring to the find input. Okay, that requires the input.
Oh, the find input. Let me actually
function. I'm not sure if that will help though.
Find input. Yeah, that'll help. See, you just you give it a list of inputs. You pass it the output reference that we already have, and it'll give you option input.
Yeah,
Okay.
this finds an input by its output reference.
Correct.
So if we have an output reference, we can find the input.
Correct.
Yeah.
All right. So one question I have is the list of inputs. We need to find that in the script address. In the current in the address of the current validator we're running, right?
No. So remember, the transaction object has a list of inputs, and
right.
yeah.
Okay. So this list of inputs is the list of inputs for the current transaction, or?
Yeah, only for the current transaction. So the transaction object is what the validator validates.
Okay. So I think we can do that. So yeah, so like I said, like the first thing we need to do is we need to find the inputs from the transaction, and we can get the transaction.
Mm-hmm.
We're running the transaction, so we have the transaction field already up here. So we need to pass in the transaction field fully without this, so that we get the.
Yeah.
We can either do that or we can do transaction.inputs. So I don't know which pattern is better. Either passing the whole transaction object or passing these two fields separately.
Passing these two
choice,
fields.
Don.
What was that, Unspent?
It's Don's choice, you know.
Yeah, for sure.
Okay, so much. Okay, so I think it makes sense to pass in the field inputs and the field extra signatories, because we're not using any other constructor, any other field in that data type.
Yeah.
So that also means we need to change this function signature to take in one more.
Okay.
Yes.
But okay, then comma. Then here we need a let statement. If so let input, I just call it reference input. Be fine.
Right, there it is. Okay.
Yes. Destructure.
Then the UTXO we're currently spending. Okay, so now we have the reference input, and then we need to find the output for this reference input. So we can basically just get the field again. Just gonna use that button. Just
can we call it Sorry, can we call it input?
Sorry?
Reference input is a named string in Cardano, right? And this isn't
Your voice is really low, Unspent.
Yeah, sounds like you're so far.
Sorry, can you hear me better?
Yes,
Yes.
yes.
Yeah.
I was just saying, isn't reference input a named field in Cardano? And so here we should call it own input or something
Yeah,
other
they
than.
usually call it own input. Yes.
All right, all right. So you can change that. Thank you.
Yeah, that's a good catch. And there's a name for that. That's like their special like code word, or there's a name. I've run into that. It's like a protected word. Like you can't use some, for instance, or let or expect. All these, it would be highlighted, you know.
Okay, so now we have the output, and now from the output, you can get two things that are important. You can get the address and also the value, because you want to make sure that the value we're sending back is not more than the value they contributed. So that's something
How
else
do
should
we
know.
know that? Do we have? Can I quickly take a look at the datum for the backer? So we don't have the value. So should we put the value as well in backer datum?
I think we should. I think it makes sense, because how do we know how much to send them, right?
I mean,
Oh,
so
we're sending
my
them a particular.
what is it?
Yeah, I would imagine we need to know how
So
much
my
value.
intuition is that it's a unique UTXO anyway. So the initial value that they send should be the same. So you're just making
All right,
sure
all
all
right.
the values sent back is what I am thinking. What do you guys think? Does that make sense?
Yeah, but how do you accomplish that? How do you know that it's the full value?
We'll have to check with the input, like the own input, value in the own input.
But yeah,
So basically what we are checking is the
is the
value
input
from the,
value the same as the output value?
yeah, same as all the value going to the output address.
Yeah. So if you would do it like all value going to this address, or all input value going to this address is X. All output value going to this address is Y. Is X equal to Y?
Correct. Or greater than or equal to Y.
Yeah, just because that's the mocktail thing or the cocktail function.
Yeah, I know. In general, every time I see it, that's what they are doing. Like, is it greater than or equal to?
Yeah.
Okay.
Meaning that it could be more.
Yeah,
Yeah.
for some weird reason. Like,
So I
you know, it
just
doesn't
think
make
because
sense.
of the transaction fee or this or that, like a little bit of extra Lovelace, otherwise it'll be too
Good
constrained.
point. Good point. Yeah, that's
Yeah,
interesting.
but what if we don't have enough money to send everyone? Like if you have 1 million backers, right? And then if each of them takes one extra ADA, and
Yeah,
then now we have 1 million ADA. We need a million more ADA. Okay, so
that's true. Uh,
anyway, we'll just let's deal with this.
yeah,
Okay.
yeah.
Okay.
So I have one question. Like the address in the output, does it represent the address that the output is currently at, or where it's from?
Yes, it represents the address that the output is currently at.
So the address in this own output, right? Own output.
Oh, you're
Address.
right.
So do we need this?
Yeah,
Is this
so
gonna help us?
I think you're right. So what we should be doing is we shouldn't be finding inputs, we should be finding outputs, right? If in the outputs it will be the address it is going to, in the inputs it'll be the address it is at.
All right. Okay. Thank you.
We need
Fine.
both. Isn't that what I just said with the X and Y, right?
Yeah, actually, we need to know. That's interesting. So we need to know the value that it's currently in, and then we need to make sure that the value it's currently with in the current address is the same value that goes to the back address. So what you
Correct.
said.
Correct.
Yeah. Otherwise, you could siphon it out, right? So you need to check both the input and the output to make sure that they're equal or greater than.
Yes.
Yeah. Okay. So, okay. And then, so we need both of them. So, okay, I'm just gonna write on. Okay, so
so it won't be the own. Oh yeah, that's right. That's right. You're right. My bad.
So let's just walk through this again. So the UTXO we're trying to spend and is the UTXO that the backer funded this campaign with, right?
Correct.
And this UTXO has a particular, its output reference basically helps us find it in the list of inputs in the transaction.
Correct.
So if we find it, and now we want to not take the output and then basically send it to the backer, right? Yeah, that's an asterisk there. I think we should put an asterisk there for that statement.
Yeah, so this is the only part I think we can't use because that address we'll be deriving is the validator address.
So we need to instead construct the address for the backer.
Construct the address, construct the address, deconstruct the address in the output section of the transaction.
Right. So we need a list of outputs, right?
Correct.
Okay. So I'm just gonna put it here. And then we're just gonna pass it again here.
I can't see.
Yeah, I can.
I'm
following
type
JS. Yeah, let me see if something's wrong. Okay.
Is everything okay?
Yeah, everything's okay.
Okay. So now we have a list of outputs, right? So these are the list of outputs that transaction is kind of. Okay, so one way to think about a transaction is it's a collection of a bunch of inputs and a bunch of outputs, whereby the inputs and outputs are UTXOs.
Yes.
And now,
so inputs and outputs are of different types. So input is of the type input, outputs are of the type output. And input is made of output reference and the output type. Did I confuse you?
Output reference and yeah. Jason, you get that?
Yeah, okay. Yeah. So they're different. Okay.
Yeah. Just the type is different. Yeah.
Okay. So now here, so now we need to check if a particular output is going to a particular address. Correct?
Correct.
Okay. And so my question is, do we need these inputs? Because the inputs here will be the thread token.
So we need the input because we need to check the value from their own input, which we got here, own value. We need to make sure this value is going back to the same amount of value is in the outputs.
All right. So okay. So we need to find a particular output. Okay. So do we go through all of the outputs and then find one, or?
We will have to. Yeah. I think we will have to check all the outputs going to a specific address, which is built with a specific verification key hash.
Okay. So I think we can use the find function, which finds things in a list. So you can check the list of outputs as
but at this point, we don't have the address.
Okay, so let's construct. Yeah, let's construct it. Okay. So let's local address equal to, okay, so I'm gonna credential and verification. So I'm gonna very key and then so Docker. So if you remember this Docker was, sorry about that. Oh no. We need to move this code somewhere else.
Where are you at? Like, I feel like I can't
Yeah.
see you. Are
I'm
you
gonna
guys
try to follow
following
him again.
Jason? Yeah.
Nah, yeah, I just reflowed and it worked.
Yeah, I'm online dot.
Maybe it's because I'm editing too. I'm trying to add the code.
What's
and I
that?
just want to put the comments.
I can't hear you well.
No.
I can't hear. We can't hear you. Yeah, Sunspent.
Sorry. I don't know. My screen looks different than Jason's. Like I have different edits than what I'm looking at on the screen.
Oh,
Okay. Let me check the.
Like I have LET. I have let backer address, and then I have the other things commented out in the code that I just wrote.
Oh, interesting.
Huh.
Can you try ahead and save, and then maybe my screen will update?
Yeah, I'm hitting save.
Make some change. Like
Another
you
change.
see on line 163, it
Mhm.
needs to have a L in front of ET.
Oh yeah, look at that.
yeah, I added
Yeah.
that.
Okay, and now press save.
Press save is Command S, right?
Yeah. Or up in the file menu.
So whenever I press Command S, this Aiken formatter starts running, and I feel like it does nothing.
Yeah, so I think that's the problem. Maybe
I also have like a more. I've written more than credential. I've written credential verification key baker datum dot baker Docker.
Oh,
So I don't know why that is not also in the. That's interesting.
huh.
Yeah, the live share possibly not ready for prime time.
I'm also I'm using the I'm
Man,
not using the web version. I'm using the VS Code version.
yeah.
I mean, yeah, I think that is the better version. Or so I thought.
can whoever started it, can you try to like refresh it? Is there something you can do, or do we have to boot everybody and all join back?
Let me see if there's
Mine's
a
the problem next time.
It might be worth it because
no, there's no
it's
refresh.
really not working without it. Weird.
Oh, there's an error here. I don't know what the error is. I found an unexpected token. Yeah, that's
That's just a coding error.
yeah. I don't know how to refresh it.
Then I would say cancel it and then send a new link.
Send new link. So, but should I send it? Because like mine, I don't think is still update. I don't know if mine is updated or not. Jason, what do you think? Like, is mine up?
Yeah, it's only missing the stuff after credential, the verification key and the baker.
So Jason, just copy your edits, and then in the new file you can just paste them in.
All right. So it's just one line. It's just one line 63.
Okay. So I am going to reshare the live.
Nice.
How do I stop it? I don't know how to stop it either.
Yeah, it's one of those on the bottom.
Shared here.
No, I think it's shared or live. Yeah, I think it's shared.
Shared. Stop collaboration.
Down to the bottom.
Okay.
Yeah.
So it's gonna...
Yes.
It's working. Yay! Oh my goodness. Well, thanks for taking the pause.
So is it the keyword credential that we are looking for? I'm just quickly going to check.
We use the payment credential one.
Payment credential, okay. Payment credential. So payment credential is just of the type credential, and credential is built with the keyword verification key, and you pass in the verification key hash to it.
Yeah.
Yeah.
And then from the credential, we can get the, okay, so now how do we construct the address? So do we?
So I don't know if we can directly construct the address. I know we can reconstruct the address. So let me actually quickly go to like a sample.
Right.
1 second. So this is Datum Dance. I should have another one. Oh, it is here. In this, I think we should be able to quickly look for it. And this is Asteria, by the way.
Yeah. So go to one of your AK files. So you're looking for an example of
Yeah, so I'm just going to check. So Asteria, because I remember address in this, I'm going to do a Command F.
Nice. Well, you look, I think this is a great pattern. I'd like to, if you look for something and then look for it in different code bases, and then
Yeah.
you get a sense of what, how people are using it. It was interesting earlier when you were saying, oh, I've seen it used this way. And once you get a familiarity with several different code bases, you start to figure out what works for you and what you understand. I think that's a good way to help understand things. Look at it
Yeah, so
different
in
ways.
this one, I think they have used the script address. So let me see if the keyword address. So there are 16 of them. Let me see. Script address. I'm just checking for like a regular address and not a script address. Expect output address, none.
Yeah. Oh, there you go. What was that last one?
Which one?
Hit the up arrow on your find. Yeah.
Oh, this is just like in the output. So they are destructuring the output field from the Asteria output. And
Aha.
these are the fields in the output. Reference script, datum, value, and address.
An address. Okay. Oh, looks good.
I think that's it, or maybe it's in something else. I'm gonna quickly check for this as well. Because I just want to find, oh, look at this. Look at, yeah, look at this. Are you guys seeing my screen here?
Yeah. So what has it got there?
So this is how they did it. When input output dot address dot payment credential is verification key is of the type verification key, then it is false. But if it is of the type script with the address payment, then it is passing. Does this pattern make sense for us?
Yeah. I think
So we would do the first one. We would check is verification key hash and then do our logic.
Right.
Yes.
Yeah.
So when input.output.address.payment credential is verification key hash, then we can destructure it and do something with that.
Correct.
And
that's what I'm thinking. But here I'm wondering the payment credential. Yeah. So we just care about the payment credential of the address. So address, they're directly accessing the payment credential part of the address without actually like destructuring the address. Okay. Okay, that makes sense to me.
Yeah, it does.
Yeah.
So my question is, which output do we find? Are we finding?
So I think we'll have to check for. So we'll be filtering the outputs for this. In the filtering logic, we'll use this, is what I'm thinking. Does it make sense? So let me, I'm just going to copy this so that I'll just copy this. I'll put it at the bottom here. So in our case, we are filtering the Asteria outputs with the list.filter function, and we'll have the outputs and we'll have the outputs as the first argument, and the second one is the function where we'll be filtering the outputs based on the when is.
That makes sense.
Yeah.
Awesome.
Jason, are you clear on it?
Yeah. Okay. So with address, same as local. Okay. So do you use an expect or do you let? I like using that.
Yeah.
Can we filter? Can you filter using let and then assign the value of the filter? There is the result of the filter to a let variable. Can I do that? Thanks.
So I think filters output is an optional one.
Oh,
So
okay. So is that a log?
Let me quickly check filter. List.filter. List.filter. So so it is not optional. It directly gives a list. So yeah, I think it's better to use expect. If we yeah, I think is it better to use expect?
Maybe the Barker has many outputs, maybe. I don't know.
Yeah. I mean, as long as there is an output. Yeah, so I think if you say this, like what you're writing would make sense to me. What do you guys think? Unspent, Ahmad, the rest of you. Does this pattern make sense? So because if it is a null, if the filter function doesn't find anything, this will fail at this line, correct?
Or if there's two outputs, it will fail.
Why would it fail? Oh, because
We're expecting one.
Oh, we are expecting exactly one. We are pattern matching. Okay.
Yeah, that's true. So do we expect more or just one?
So can we do this like this?
Oh yeah.
Or would it in this case, if we
Don't
write
put it in
something,
the. I think if you don't want to expect it as a single thing in an array, then you would just do let
I
and
think
assign it and
that,
remove the array, I think.
remove the array. So just like remove this and say, just call it backer outputs.
Yeah.
Okay.
But I think expecting it to be one is what we want. We want one input and one output with the same values. But
should we enforce that rule?
Yeah, we don't really care. That's the other thing is it doesn't really benefit us. You can see on my
it does
example,
benefit us by just making things easier for us to write.
That would be the most important. Yeah, is ease of right. You can see on my example on line 171 and 172. I'm just checking value of outputs is greater than or equal to the value of the inputs.
The total value, you're doing like that for the total value, right?
Get all value to outputs
Uh-huh.
of the own output address. So it doesn't care if it's one output or three, and we're not even destructuring it to like assign it to a variable. We're just passing all of the outputs into the function get all value to, and then with the address that we're checking. And so that would get all the value going to whatever the own output. And then we compare, like with the pipe operator, value is greater than or equal to, and then we do the same sort of function but with the inputs. So we get all the value to the inputs.
But the problem is we don't have the output address. Like we don't have like an exact address for the output. We only have the verification key hash.
I thought, I'm looking at own input dot address.
Oh yeah, for the own input, yes, own input we should have the address. But
Won't
how?
it be the same?
No,
Isn't it
no,
supposed
no.
to go to the same person?
No. Own input, the address in the own input is the address of the validator, not the validator of the guy who sent it. Remember, you only clarified this for me.
Yeah. You're right. So, but I thought we were getting that input. I thought we were getting the person's address using the input verification key.
So we are not getting the address. We are just making sure the verification key, the address is built with the verification key.
Okay. Yeah. So sorry, I didn't mean to just.
Hey, no, that's
No,
a good
you're
rabbit
fine.
hole.
You're fine.
Yeah.
All right. So do you use a filter or do you use a find? Because there's a find function that returns a option.
I think find just gives one, right?
Yeah. So do you want one or? Let's use this. I think let's use filter and then yeah.
Yeah, just because I am thinking there can be. Oh, yeah. So this is where I'm confused. What if the same guy backs the campaign twice? Then we'd be a little bit
Ooh.
screwed, right?
I think we'll have to spend it again, right? Like
No, so in the outputs, what are we basically checking? Because if this is two different amounts,
yeah, oh yeah,
you know.
yeah, I get it. Yeah. That's an interesting one. So can we? But we only spend in one input though, right?
Yes. We can only spend one. We can only check for one input at a time. Can we spend or not?
So I
And
think in the filter we can check for the value and for the address.
value and the address. Yeah, I guess like, can we do that for the filter?
Yeah.
So we're talking about the difference between filter or find input. Is that where we're sort of trying to figure out which is the best one to use in this case?
So filter will give you filter will give you a list of all the outputs, but find will just do the first matching one, I think. First element satisfying the given predicate. Yeah.
Oh, look at the docs.
Okay, I think. So filter, I think filter just filters. Like you have a list of, let's say, 5 things, and then you want to filter them, and then at the end you'll get a list of 3 things, right?
Yeah.
So I think what we do here is we filter all the outputs for the ones that are matching the address and the ones that are matching the value. So after we match the address, we can, instead of returning true, we can now check again the value.
Yes. Yeah.
Okay.
Okay.
Then, so here,
Okay.
Datum. Maybe you should probably call this some other name. Okay. It's not datum out, is it? Should you call this datum Boca datum instead of datum out? Makes more
Yeah.
sense. And we also have to move this code up there. But that's okay.
Yeah.
And I might have to.
So here, I don't think you have to do this. I think we can, if we can just put this here, I think it'll do the check automatically, right? Instead of
Yeah.
instead of first doing, we are checking only if it's a verification key here. Instead of that, we can do both. We can check if it's a verification key of the backer datum.backer.
Yeah. And then we don't have we don't need this on state.
Yeah.
Done. Okay. So I don't. So value, is it value greater than or equal to, or was it?
I would think it'll.
I think for now we can just do one of them, and then is this a function? Could you?
Yeah, I'll check.
What
Value
is?
GQ, right?
Yeah.
So that is from mocktail. Sorry, cocktail. Value gec. So it is a function that takes the value as the first argument, and it takes a second value and it just compares.
Well, it's with the greater is the first one, and the smaller is the second one, and then it tells you if it's yes or if that's correct, basically.
Yes, correct.
Yeah.
Okay, so we want the greater to be
The
the
first.
value. Yeah, the first.
What you're
which one?
expecting. Yeah.
Yes, first value
What
is
you're
greater.
expecting? What you're expecting to spend, or what you're expecting to?
So we are expecting the output to be greater or equal to.
Use the keyword there.
Okay. So greater than the input, right?
Yes.
Greater than or equal to. Okay. All right. And then
Yeah.
So I think I have a small issue here, Jason.
Okay.
In this function, I don't know if we have access to both outputs and inputs, because we only passed outputs as the argument. So this function doesn't have access to own input
Right.
value.
Really? It doesn't pass it? Okay. So you have to pass it in here as well.
I don't know if we can. I don't think we can directly pass it here. You know what I'm saying?
It doesn't check outside the scope.
Yeah, so I think we'll have to separate our concerns. In the first one, we just have to filter it out based on verification key,
Oh, okay.
and then we'll have to do this outside.
All right. No worries. So this then is true. How do you?
Yeah, so It is taking one output at a time, and we are checking if output, where is that? Yeah, then we'll have to say instead of when, we say when, we don't even say this, we just say when output payment dot credential. Oh yeah, so I think we can keep this. Actually, you can keep the when part. When output of credential. This is true, otherwise false. I think that's fine.
Okay.
That's what I'm thinking. So if it is true, then that output will show up in our final thing. Otherwise, it won't.
All right, and then we filter again now. Is there a way to, can you do it in the, can you nest it here, or it will be too unreadable? Like we just add another filter on top of this.
Can you repeat that for me?
Oh, we, instead of having it in a separate line, we can add another filter here, or it will be too.
I mean, we can if you just want to like go for it, like filter of a filter. Yeah.
Yeah, I think this is more
So
readable.
how would we?
How do we?
Yeah. I'm just thinking about what the second filter will have access to. Or it'll have access to the inputs this time. Okay.
No, but still, I think we're still running the same problem. Because this function only takes in the outputs that are in this part, right?
Yes.
This inline, this anonymous function here takes. Or another thing we can do is we can define our own function. But it should be able to take in an output. Like it's a general function, right? Like if you look at the signal.
So now in this case we have all the backer outputs. What is the second filter for? I forget.
Value, the value. We need to check also the value is equal.
Okay. So I think we have like a function to like basically get all the value. Like, to get all the value from the outputs. I think there is a value function. Value tokens. Vodka value.
So get all
Value. Oh, here it is. Get all value to address is there. Get all value from address is there. I think, or yeah. So I think one of these two, but we don't have the address. Value length. Calculate the length of value. I don't know what that means. Value tokens. I feel like
could you go to the filter function?
yeah, let's go to filter here. Filter list dot filter. Where is list? Okay, we are in list. Modifying, extracting.
There it is.
What?
The filter map. Yeah. Use a list of elements. Predicate.
So this predicate only takes in
A bool
A's.
function.
So it only takes in A's. You can't give it any other thing.
So filter.map, on the other hand, maps a function to each input, I think. Here. Oh, no. Are we mapping? Oh, so you need to get all the value, right? So you'll have to do the folder function. I forgot. Fold left or fold right.
Oh,
So
man.
you'll get all the value in one go.
All right. And then we check the value.
L.
Yeah.
Oh, okay. I see. Yeah, that works. Okay. Okay, so we need so backer outputs value, right?
Yes.
Okay, so we need the what are the arguments?
So
again?
it takes a list
So
and
that's
it takes 0, which is, I think,
this is the
oh,
accumulator, the initial value.
it is the total value.
Initial.
Yeah.
Yeah.
And then it takes a function which takes A and B. B is the total value and A is the list, like each part of the list, and it gives a combined value, and it keeps doing that for all of them. Okay.
How should I?
So so backer output, right? So the first one will be output and the second one will be 0. Total, yeah.
So the first one is the output.
Yeah, output. And second one is total.
And then output dot value. We add it to, okay, how do you add values? Can you just add them?
How do you add value?
You can just do math.
Yeah.
Just
No,
add them, okay.
because the problem. So we should also assume that the UTXOs they are sending only have ADA and nothing
ADA.
else, right?
Yeah.
I think we should make that a rule. Don't fucking send random tokens to our campaign.
Why does it
You
matter?
can't.
It doesn't matter, but because the value
So I accidentally, because you can't enforce rules on the input, so I accidentally
right.
send mine with an NFT that I didn't know was there, and now it's locked forever. It can't be part of anything.
yeah, you sent like a CryptoPunk by mistake, and that's it.
What?
Yeah, so how do we add this? So in that case, if oh, so two Lovelace, I remember two Lovelace and two something.
I think if you go to the value documentation, I think we can add, and then you can specify that we can only add
Value documentation, value.
or just, yeah, this value.
Yeah. Contains index by policy ID and asset name. Okay. Oh, we can use these functions. No, can we? Only these are constructor functions, not extractor functions.
If we do the accumulator in our folder function of a value, won't it accumulate the values?
Yeah, that's what we are doing. We're just trying to figure out how to add the values.
Yeah.
Because I know there is an accumulator in
Could you
cocktail,
scroll down?
vodka value, get all value to get all value from.
Yeah, there you go.
What?
Get all value.
Source. Yeah,
Get
go
all
to the
the-
source of get all value to.
Ooh,
Get all
yes,
value
yes.
to.
So this what Unspin is doing
Okay,
is he's
yeah.
like, okay,
This is how
this
they're
might tell
adding.
us, look, merge. They're using
Merge.
folder. What is?
So output 0, just like we did, and output accumulated value we got till here. And they're saying if output.address is equal to address, merge, I think this is the function they use, merge
Okay.
accumulated value, comma output value. So we don't need the if statement, we just say merge.
Well, wait, why? If output.address equals address, then merge, else just return the accumulated value.
So because we already filtered, in our case, we already filtered the addresses. We are not worried about the addresses because all the addresses are the same anyway.
There you go. Then
Exactly.
perfect.
So we just wanted we need the merge.
We
That's
just
how
need-
you would add values.
Yes.
Can we look at merge, maybe?
Yeah, look up merge.
Yeah.
Where do I look up for merge? I'm guessing it should be like built-in or prelude, or is merge here? MERG. Oh,
I
it's here.
never.
Oh, it's in
Yeah.
assets. Okay. So merge
Oh.
is it takes the left value and right value and just gives value. Okay, perfect. So just merge.
Merge. Okay.
Yeah.
Look at the
Uh,
source of merge. Sorry. Is that okay?
What is it?
yeah, of course. Yeah, let's do it.
What did you say? I
Uh,
missed it.
Okay.
Look up the source of merge.
Source of merge, yes. Oof, look at this.
I guess pretty low level.
Oh,
Yeah.
so left value, right value. So both of them are values and it gives a value. So it is using the value, keyword value for constructing something. Dict dot union with v0 inner dot inner.
Left.
v1 dot inner function.
Okay, that's probably good enough. I just for me that's enough. I'm like, yeah, okay.
Yeah, this is a pretty low level function. Yeah.
It's using dicts, which I have not used enough of to be familiar. But my guess is the union with and dot inner, like those are kind of just part of dictionaries. But yeah, I'm okay with that for now. We can go back.
we could take a look at Dict,
I mean, we
Let's
know
continue.
like what a dict is.
On something. So
but just in that would be Aiken, like how Aiken handles.
So if you
Yeah.
want to take a look at dict,
There you
and
go. Yeah, yeah,
is there a
Yeah.
union with? Oh, here it is, combining union with.
yeah,
So
yeah.
it takes
look
a
at that.
left, right, with, and it takes a function, and it gives the key value.
Could you go to the definition of value and then scroll to the bottom? There's a to dict thing that
Nice.
reconstructs the value to a dictionary. And then just go to the bottom.
All the way to the bottom.
Yeah, although.
Oh, to dict.
Okay. So now you
Yeah.
can see. So I think it's combining values that have the same policy ID and asset names.
And
The mod.
and integer as well, because
Yeah.
So it's
So
assets.
it is a dictionary of dictionaries.
Yeah.
Because asset is a dictionary.
What do you asset
It's
is
a
not a dictionary.
Why do you say it's a dictionary? Oh, I see. Right in there. Yeah, yeah. Policy ID.
So policy
that has
ID is the key
Yeah,
for the
yeah.
first set of dictionaries, for the next set of dictionaries. Yeah.
Yeah.
Okay.
We've seen that. We've seen that before.
Yeah. Okay.
So do you want to look at the merge function and see how it's
Yeah.
doing that, or do you get the gist?
Yeah. So here we have like the merge function, but merge function is using union with.
let's just assume that's combining it. So you're taking the vo.inner, which let's just assume is some part of the dictionary of the left value, and the v1 of the inner. So it's the same part of the a and the b. And then we have a new function which result equals another dict.union with, and then taking the parameter of that function.
I think inner checks the second dict.
Yeah, that's what I'm thinking. Inner just sounds like. And by the way, CodeCow, you got cut off, so we just started talking. So yeah, I agree. Like inner sounds like the second inner dictionary.
No, that's the first dictionary, and then the A0 and A1 would be the inner dictionary, right?
I mean, yeah, that could
Yeah.
be, could be. So left value is V0, right
Could you
value,
go to union with?
yes, union with. So yeah, so left is a dictionary, right is a dictionary, and they're unioning with a function. which takes in a byte array and both those values, and it gives
So
out an optional value.
So the values in our case are dictionaries with asset name and amount. Because that's we're unioning the value with the second dictionaries with this function that takes in the second dictionaries. And
Yeah.
then in that second dictionary, we're unioning again with yeah. Could you go back to the other one?
Other one as in
Merge.
merge.
Yeah.
The function
Yeah,
definition or
the function definition. Yeah. Like the source.
Yeah. So I still don't understand the union with and merge. Like merge, it feels like it's just adding the values. The union with feels a little bit sketchy to me because there's an additional function in there.
Could you go to source, view source?
Source of merge.
Merge, yeah. Okay.
So this
So
is the
now,
one. Yeah.
So now, this fn a0 a1 is the width function, and then in a0 and a1 are dictionaries that have asset name and value and amount, and then the result is a dict union with a0 the two dictionaries, and then these are the quantities. So the quantities are the
So Q0, Q1 are the quantities. Okay.
yeah, the integers, and then we add them up, and then yeah, that's basically what you're doing.
Okay.
And I think
Code cow, you're too low.
Damn, it sucks. I wanted you to read. If Q is quantity, what is V and what is A?
So V is the one of the dictionaries, A is the other dictionary. So if you look here, you have this value and this value, right? Wait, but values are not dictionaries.
they are they are to dict.
Oh, where is to dict? Did they say to dict anywhere? No. Is value a dictionary? No. Is it?
Yeah, like okay. Yeah, the constructor. That's why they're deconstructing it. Like if you look at the merge thing.
Oh, so just the build, yeah.
Yeah, you can see the value here. They're deconstructing value into the dictionaries.
Oh.
I don't know how do you construct value? Could you?
So I thought of value as just an object with two fields, and the two fields are basically like you look here. So I
But
think
what's an object? Isn't an object maybe a dict?
I mean, it could be a dict. Yeah, you're right. So value, actually, the best way. God, so value has policy ID, and is value naturally a dictionary of dictionaries with like
go to the code. Go to the code of value. Yeah, the source of value.
Oh, it is a dictionary of dictionaries.
And they use this inner. What is that about?
I don't think there is an object, right, Harsha? Like when we think of objects, the type in Aiken is a dictionary, correct?
Yeah. I mean, not is it always a dictionary? I don't think it's always a dictionary, but yeah, it's an object of the type dictionary. Object of the type dictionary of dictionaries.
But the data structure, like in JavaScript, when you have an object or in any other language, what I would think of it as an object, I think in Aiken is a dictionary. Maybe that confuses people.
Maybe it is. Is it?
I think it's just like a type constructor which has a value, which has a field of inner, and that's why in the merge function we're using dot inner.
Yeah.
And then
Yeah, I think that makes sense. So value is an object with the field inner, and the inner field is just a dictionary of dictionaries.
Probe type value. This type contains some. Will never contain
Yeah.
I think this makes sense to me. Yeah.
Yeah. So, okay, so now we have the total values
Yes.
Yeah.
in the output. Okay.
Yeah.
Back to the
So now what do we do with them? So we need to check. So we need now to check.
We have to check if so so I am thinking what we have to do is check total value from that specific backer in the inputs, and then check if it is greater than or equal to the total value to that backer in the outputs. So we'll have to check all the inputs from the transaction as opposed to just that one UTXO we are spending.
Okay.
That's what I'm thinking. But does that have any logical flaws?
That's what I was doing earlier on lines 179.
Yeah, I think that does make sense. At that point, so I think this makes sense, but we'll just have to check it with like with a little bit like this, like with the credential verification key stuff.
Yeah, so I mean, I feel like we should put logic instead of that verification key error to true. Instead of the true, we would have other functions or other logic. Because like when we are in that verification key, then we do things, right?
So that's the same issue like Jason got into, because inside this we only have access to the output, this specific output, and nothing else. Like we don't have access to any other information because the argument in this filter function is only the outputs.
Yeah, okay.
So I think if
but doesn't it have the scope of the whole validator though?
But not inside this, not inside the filter function. It will have scope of the validator, but not inside this function, I think.
But like on line 160, let own input value.
160.
It was right.
Scrolled away from it.
I mean, I'm just following Jason.
I think it has access to outside scope, because if you look at this, the exterior function, it has this exterior validator address, which is not here. So I think
Right.
So maybe it does, right? It
Yeah,
does.
It's that's lexical scope, right?
Yeah. Wait, what does that
mean?
Right.
Oh shit! The scope is killing me. Okay.
Yeah, it's one of those things that we learn, and from the first lessons, and it's just like yeah, it can bite you. So figuring out the scope is an important part of where those variables can be accessed for sure.
So I think we have access to value here, but I think maybe it's a good exercise. We went into this, we took it outside, so now we can even put this line back in here if you want to.
Are you writing something, Jason? Because I can't see it.
No, I'm not writing. I'm saying like
Okay.
if we instead of, so now we have the total value, we can check that the value of the output is, because
like when you say value of outputs, are you saying total value in the filtered outputs?
Yeah. We should check that should be greater than or equal to input value, right?
Yeah, input values to that specific address.
Yeah. So on input value is the input you're spending. It's a UTXO we're spending. So
yes.
that UTXO you're spending should have either less value or equal value to the outputs going to this particular address.
So no, I think that will result in a wrong logic. Just because we cannot check only the value from the own input that we are spending. We have to check all the value from the inputs that are going to that specific address and check if they are greater than or equal to all the values, the sum of all the value going to the specific address in the output. We can't just check this.
Okay, so I think instead of checking the inputs for the address, I think we should check the inputs for the datum. We should check that the datum contains the key hash for the buckle. Make sense?
Yes.
So now and then we filter those inputs which have the datum equal to the Baker datum, and then we do what you're saying. We compare all those inputs.
Yes. So you're basically saying the filter function, the filtering function inside the filter will change, right? That's it.
No. The filter, we need to filter now inputs. Here we're filtering outputs. Now we need to filter inputs.
Yes, correct. Yes.
All right. So let's
Okay. Nice.
so we need to check when this input dot output dot datum is that field?
Yeah. So output dot datum dot backer, I think.
Yeah, makes sense.
The Baker. Okay, yeah.
Or
no, but this is the output in the UTXO in the inputs. So I don't know if we've destructured it into
outputs. Yep.
So
no, the input. This is from the input field, right? Inputs. The input is of the type like output reference plus output.
Right.
And then
you get that output. Yeah.
Yeah. So you can do dot datum dot backer. I think you can do that. Yeah. If there is a backer field,
Right.
then
I think what I had in mind was
go for it. Yeah.
And then any other case.
Oh yeah. Yes.
So it's and then if it's any other thing. So do you have anything like that? Yeah.
So here I am saying instead of just checking the backer datum, we have access to the exact verification key hash, right? Because of our the UTXO input that we are spending, we can directly put it here, I think.
Oh, okay. So we can do B datum equals.
Yeah, equals like where is that UTXO? We filtered our own input. Yeah, own input dot what is that? Own input dot output dot datum dot backer.
No, I think when you check the so this datum, the B datum is the datum from the input, right?
Yes,
correct. So this datum could contain. So it's a Backer datum. So and then if it's it could be over different Backer. It could be of
correct. So B datum dot backer should be equal to own input dot yeah, own input dot output. Yeah.
Nice. I think it should just be equal to Baker datum dot Backer.
Oh yeah. So because we have direct access to like the datum, right? Yeah, absolutely, yeah.
Okay, this might be confusing because it's
Yeah.
the same. Yeah. Anyway.
Well, yep. I am mindful of the time.
Oh,
We
shit,
are getting
forward.
into the 90-minute, past the 90-minute
Okay.
mark now.
So we
Um,
can just finish the inputs value. Just
Yeah.
check this.
Yeah, I think that's correct. Oh, input dot. We don't have to say backer input. So we'll have to put like, yeah, input dot output dot value. I think there.
Yep.
Yeah.
And then we need to check the check this one. Okay, now we need just this check. Can you do an expect value? Expect here?
Expect where?
Here. Expect value greater than or equal to.
But what are you expecting? Are you expecting? But I don't know if you can do an expect because it'll say true or false, right?
Oh, okay. So, okay. Yeah, but okay. Makes sense. So now we have everything we need. So now I think we can actually not do the check, the final check.
Yeah. So the final check will be the greater than or equal to check. That is one. That's the only check, right? Or is there any other
I
check?
think we can do that for now. And then check if it compiles and then, yeah.
Oh, compiling, I feel like we still need to write inputs. Imports.
Oh, yeah. Okay. So I think now this is makes sense. Okay. So now here we don't need this anymore. Sorry. We don't need that anymore. Okay. Okay. So now that we have both the input values and the output values, we can compare them to see if they are greater than or equal to each other. And
Yes.
so
Question mark. No. You can just put like a question mark and that should be it. So just end the logic with like a question mark here and that should be it. No, not here, but at the end, and then that should be it. That's the last statement.
Okay.
Oh, there's another question mark here that I can remove.
All right, we should check it's signed by the.
Oh yeah, we need to check if. No, but it is. Yeah, we need. Oh, you need the other checks. Yeah, it is if the campaign ID and the campaign ID matches. If the signer is like the campaign initiator, like those basic checks that are done in everything else.
Yeah, so we can
Yeah,
just add
same these guys. Yes, these guys.
on the value. Just copy that. This returns a bool, right?
Yes.
Okay. I think that's good to start with.
Yeah. How are you guys feeling? Like, do you think we covered all the necessary bases in this one? Or are you guys confused at this moment? Like, how are you guys feeling?
No, I mean, for my part, once again, it worked. We had a validator that we investigated. Jason, as the Don, helped us drill down into something, and then we all sort of, went through the documentation and triangulated our knowledge. Yeah, in my mind, that worked pretty good.